Here we're looking at order of operations. Now the operations we're considering add, subtract, multiply, and divide. It's kind of unusual. People look at those operations and think there's an order to them. Well, there is sort of a priority. That's what I'll kind of refer to it at some points, and let's talk about why that happened. It isn't just that we agreed on it. There's a reason for this. It starts way, way back when we had 2 plus 2 plus 2. Well, yeah, that equals 6, but if you look at it this way, we had 3 times 2 gave us 6. Multiplication, whenever you see it, is the exact same thing as a whole bunch of addition taking place, kind of in shorthand. We summarized a whole bunch of stuff up there. And the same thing happens with exponents. When you have 2 times 2 times 2, well, that's 8, but we can also write it in shorthand. There are 3 of them, and that 2 is raised to the third power. That's what exponents are. So exponents are a shorthand version of multiplication. Multiplication is a shorthand version of addition. And that tells us, at least an order between these two guys, that wait a second, multiplication has a higher priority, and, ooh, we should add that other guy over there, exponents. Yeah, that in general, this guy has to be taken care of before you can do any multiplication because you've got a lot of shorthand. Let's do an example, make sure we can see this. If we see 2 plus 3 times 7, if you just read this left to right, you get 2 plus 3 is 5 times 7 is 35. However, if you go the other way, 7 times 3 is 21 plus 2 is 23. So we could get a 35 or a 23 out of this. And that should bother you. Oh, we can't get two separate answers for the same problem. Indeed, we can't. And so we look at this and say, okay, what's really happening? Well, this is really 7 plus 7 plus 7. That's what 3 times 7 really is. 7 plus 7 plus 7 is 21 plus 2 is 23. This is the right answer. So if we violate that and say, oh, 2 plus 3 is 5, and then do stuff, we end up with the wrong answer based on what multiplication really is. So this says, yes, always do multiplication. Let's write it over here. Always do multiplication. It's on kind of a higher level than addition. It has a higher priority. Let's do one that has an exponent in it. 3 plus 4 times 2 to the 5th power. And yeah, that's exactly what happens here. Is 2 to the 5th power is 2 times 2 times 2 times 2 times 2, all the way sucked up into that guy. So that is really a 32. So we really have 3 plus 4 times 32. And just like what we said before, this is really 32 plus 32 plus 32 plus 32. So before we add the 3 and change the problem, we need to take care of that multiplication. 4 times 32, that's 128. So adding 3 plus 128. So exponents are like the top dog. Then this multiplication happens and then the addition. Now we haven't taken care of subtraction and division. So let's look at those for a minute. If I have 3 plus a negative number, so this is just addition, it's the same as 3 minus 5. We get negative 2 either way. So subtraction, as far as importance, can be always made into an addition problem. So it's really on the same level as addition all the time. There's not really a priority between addition and subtraction. They're kind of the same thing, just with opposite numbers. So if you have something like 8 minus 3 plus 4, you don't say, oh, hey, we're going to take 3 plus 4 is 7. Don't do that. You have 8 minus 3 is 5 plus 4 is 9. It's just a normal thing. And if this is all addition, you could write this out as 8 plus a negative 3 plus 4, like that. And you can see you can do it in any order you wanted to. 8 plus 4 is 12, minus 3 is 9. 4 minus 3 is 1, plus 8 is 9, and you'll get the same thing. So these guys are really on the same level. You can be safe and do it left to right. That'll be safe. Or you can always do the subtraction one first, and that will also be safe. Let's look at multiplication and division. If I have 12 divided by 4, that's the exact same problem as 12 times 1/4. And again, as far as importance goes, these are the exact same problem. So anytime you have a division problem, it can be a multiplication problem. They're the exact same importance as far as that goes. So multiplication and division. Again, if you want to be safe, you can go left to right. Or if you always do the division and turn it into a multiplication problem, just like subtraction turned into an addition, you will always be safe with that one. So this is how the operations are ordered. Let's do a good big example here. 3 plus 5 minus 6 to the second power plus 4 times 7. Now this has a very particular order of priority in which we need to take care of these things. Let's walk down through that. Okay, first thing we'd have to do this exponent. So this is really 3 plus 5 minus 36. So we take care of those exponents first, plus 4 times 7. Now before we can add any of these numbers, now you could add these over here, but this has to be taken care of. You can't add that 4 without it being times to the 7 first, because there's shorthand here. So this guy is 28. So now we just have 3 plus 5 minus 36 plus 28. And again, this just left to right with addition and subtraction. So 3 plus 5 is 8, minus 36 is a negative 28, plus 28, that's a 0. Oh my word, that was surprising. So where do parentheses come in? You guys have seen those before. Well, let's look at it. If I, as a teacher, say, you know what, I want you to actually do this 5 minus the 6 before you square it, I can put a parentheses around that. Or I could put parentheses around anything else to disrupt this normal order. So parentheses aren't actually an operation. They are a grouping symbol that says, hey, I'm making this the priority. So it's actually, it can go anywhere and just disrupt it. But that's all it really means. Let's erase this and redo this problem. There, that should do it. Now notice this parenthesis says, hey, you've got to do this subtraction because it's all one number before you square it. So we actually put subtraction up here before exponent because of this parenthesis. 3 plus, this is 5 minus 6 is a negative 1 squared plus 4 times 7. 3 plus negative 1 times negative 1 is 1 plus 28. 3 plus 1 is 4 plus 28 is 32. And there we have it. That's where parentheses comes in. So I would like to talk just for a moment about some acronyms that may help you remember this. The first acronym that some of you may be familiar with already is Pemdas. P-E-M-D-A-S. And people will say, please excuse my dear Aunt Sally. And they're like, oh, this is the order of operations. You'll notice they put a P first. It's not really an operation, but it may help you remember that that can take top priority. And then exponents, multiplication, division, addition, subtraction. Now, for those of you that are familiar with that, multiplication and division, if you remember this correctly, must go left to right. If you don't, you could mess it up. Here's an example of that. I'll put another one down here. Addition, subtraction must happen left to right. 16 divided by 4 times 2. If you do this with multiplication above division, you will say 4 times 2 is 8, 16 divided by 8, and you'll give the answer as 2. However, if you punch this in your calculator, you'll find out the answer is really an 8. 16 divided by 4 is 4 times 2 is 8, and that's the correct thing. So putting multiplication before division is technically not correct. Now, and the same thing with addition and subtraction. If I did something like 12 minus 3 plus 5, just common sense, this is 12 minus 3 is 9 plus 5. The real answer is 14. But if you follow this verbatim without knowing what's going on, you could do 3 plus 5 is 8, 12 minus 8 is 4, and it's wrong. So you have to be careful with PEMDAS that you don't put the division before the multiplication before the division, or the subtraction before the addition. So left to right, if you learn it this way. There is another one, if you would like to, PED MSA. At least in British speaking countries, they'll put a bedmas. They'll put that D first which some people are like, wait, you messed up. Actually, if you put the D before the M, you don't have to remember left to right. It will always work. For example, this division sign, because it can always be made a multiplication sign. Notice now we're in multiplication, we can go in any order we want. So if you do the division first, you've taken care of that issue. So this, you can actually follow this order as you wish, but this one, if you remember, Pemdas must go left to right. Let's do one more of them. So let's do one final example and put some of these together. 3 minus parentheses 2 plus 4 times 1 all to the square power, let's put a 2 there, 4 times 2, all to the second power, plus 4 divided by 2 times 2 on the end. Okay, let's see what goes on. All right, so first these parentheses are saying let's get this stuff in here done as all one thing before we square it. So 4 times 2, this is 8. 2 plus 8 is a 10. So this is really 3 minus 10 to the second power plus 4 divided by 2 times 2. Now, exponents, this is going to be 3 minus 100 plus, and then this section over here, remember, if we're going to go multiplication, division like that, we have to go left to right. So 4 divided by 2 is 2 times 2 is 4. Now again, that goes left to right, or if you want to take care of the division first, either way will get you the right answer. So 3 minus 100 plus 4, and remember, addition is not necessarily in front of subtraction, it's left to right here, or we could do the subtraction first. 3 minus 100 is negative 97, plus 4 is negative 93. And there you have it. Good.